So we've learned to add, subtract, multiply, and divide with rational numbers, and now we're going to be working with exponents. The definition of exponents: for x is an element of the natural numbers, b to the x is the product of x factors of b. So we have x factors of b. The repeated factor b is called the base. The exponent, which is x, indicates how many times b is used as a factor. So that would look like this: b to the x. b is the repeated factor, and x tells us how many times we're multiplying b by itself. So when numbers are written this way, they are said to be in exponential form or exponential notation. So a few examples and how we say them. This one right here, this can be said in two different ways. We can say 5 to the second power. Another way we can say this is 5 squared, and the reason we say 5 squared is because when we learn about area, here is a square, that's 5 by 5, so that is 5 squared. The next one I have here is 6 to the third power. So we name the base first, and then the power second. So that's 6 to the third power, which is 6 times 6 times 6. That also can be 6 cubed, because if you have a cube and each length is 6, that's 3 different dimensions, so 6 cubed. And then 9 to the fourth, which is 9 times 9 times 9 times 9. And we don't have a special way like squared or cubed to say this, so from the fourth upward, we're just saying to the fourth power, to the fifth power, to the sixth power, stuff like that. So here's some examples. Write each of the following in exponential form. Well, here we have 2 multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. So 2 would be our base, and then to the 7th power, because 2 is a repeated factor. Part B, this has negatives in it, but negative 3, 1, 2, 3, 4 is a factor 4 times. Now we have to be careful how we write this, because we want negative 3 multiplied by itself 4 times. And so you want to put that in parentheses. So if you look down here, we just want to make a distinction between these two things. The way that these are written will give you two different answers. We read them really the same. Negative 3 to the fourth. Well, that, which we'll talk about later, you want to work with exponents first. So we can really think that's negative 1 times 3 to the fourth. So the 4 just goes with the 3 to the fourth, but it's negative. And so we have negative 1 times 3 to the fourth. 3 to the fourth is 3 times 3 times 3 times 3. That ends up being 81. So that's a negative 81. On the lower part here, negative 3 to the fourth, which is what we wrote up here for our answer, is negative 3 multiplied by itself 4 times. So we can think of this: negative times a negative we know is positive. So this is 9. Another negative times a negative is positive, so that's positive 9. And in this case, this is a positive 81. And so you see that it is important to have the distinction there, because you could get a negative or you could get a positive. Next example, it says evaluate the following exponential forms. So evaluate means find the value of it. So for this one, 9 cubed, well, we know that's 9 times 9 times 9. Multiplying across, 9 times 9 is 81. So that's 81 times 9. And so we want to multiply these to figure out what that is equal to. We get 9, 72. So that's 729. The next one, we have this negative 7 in parentheses. So that's negative 7 times negative 7 times negative 7 times negative 7. We have 4 negatives, so that means we're going to have a positive answer. And we can work our way through. 7 times 7 is 49. This 7 times 7 is 49. And so 49 times 49 is 2,401. And so that's negative 7 to the 4th power. In this last one, we have a negative 4 squared. So that's kind of like this example right here. It's a negative 1 times 4 squared, because the parentheses aren't there to show that it would be negative 4 raised to the 2nd power. We know that squared just goes to the 4, and that's a negative on the outside. So here we have a negative 1. 4 squared is 16, so that's negative 16. So that's your introduction to exponents. It's repeated multiplication, and you have to be careful with negatives. So now what we're going to do is there's several different properties or rules that we come across when we work with exponents that are going to make them easier to work with. So we're going to investigate some of these rules, come up with the rules, and then once we have them, we're going to use them in some problems. So our rules for exponents, the first one is the product property. The investigation says write out x cubed times x to the 5th in expanded form and then simplify. Expanded form means I'm going to write this out using the definition. So x cubed is x times x times x. And we're multiplying that by x to the 5th, which is x times x times x times x times x. Well, this is just x multiplied by itself 8 times. So this is x to the 8th. So what we're doing is we're thinking, is there maybe an easier way of figuring that problem out instead of writing out all the factors and determining what it's equal to? We're going to look at another one, a to the 7th times just a. This middle a doesn't have an exponent, so it's just a. And we're going to multiply that by a to the 4th. And we see when we multiply those, we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 a's. So that is a to the 12th. So we want to see, is there a rule that we could come up with? X cubed times x to the 5th was simply x to the 8th. A to the 7th times a to the 4th was a to the 12th. Well, you might notice that 3 plus 5 is 8. 7 plus 1 plus 4 is 12. So the rule for this is when multiplying powers with the same base, add the exponents. So we can just add the exponents. Here it is in the symbols form. X to the a times x to the b equals x to the a plus b. You can just add those exponents. So looking at this example down here, we have b squared times b cubed times b, and when you just have a b, this means b to the 1st. We don't have to write it in there, but that's what that means. And so this is all multiplying, so all we have to do is add those exponents. So we have 2 plus 3 plus 1, and that's equal to b to the 6th. So just adding the exponents. So that's the rule for the product property. Now we're going to look at the power property, and this, we have an investigation. It says write x cubed to the 5th in expanded form and then simplify. And I'm going to write this not all the way out in expanded form, but just partly. And so we have x cubed to the 5th power. That just means I want x cubed as a factor 5 times. So we have x cubed times x cubed times x cubed times x cubed times x cubed. And we know from our last one, we can just really write this as x, and we can add the exponents. 3 plus 3 plus 3. Well, we learned back in elementary that you have repeated addition, you can just multiply. So this is really x to the 3 times 5, which is x to the 15. And so hopefully what you notice here, another property, that if we have a power raised to a power, we have 3x cubed to the 5th, that's just going to be x to the 3 times 5, which is x to the 15th. So our rules for this, in words, when a power is raised to a power, you can multiply the exponents. In symbols, we can say x to the a raised to the b power is just x to the a times b. And so we're going to show this in an example here. Simplify m to the 6th raised to the 7th power. Well, that fits this form here that we've been talking about. So we have m to the 6th times 7 is m to the 42nd. And so when it's a power raised to a power, you can multiply. Notice the difference from the last rule, just so you see. The last one that we talked about, the product property, would have been m to the 6th times m to the 7th. So see the difference between these two. Here you would just add the exponents. 6 plus 7 is 13. Our next property we're going to look at is the quotient property. So here we're dividing. So we're going to write this in expanded form. So c to the 6th. In the denominator we have c to the 4th. And we know that something divided by itself is just 1. So c divided by c, that's just 1. Another one here, that just becomes a 1. This just becomes a 1. This becomes a 1. So we're really left with c squared over 1, which is just c squared. So we've done this a couple times. So what do you think the rule is? We have c to the 6th over c to the 4th. We get an answer of c squared. The property here, when dividing powers with the same base, you can subtract the exponents. In symbols it looks like this. X to the a over x to the b is x to the a minus b. You just simply subtract those. Now realize with division you see this in a couple different forms. So simplify 10 to the 7th over 10 to the 4th. Well, that's the same base and that's division. This fraction means division. So we can just do 10 to the 7 minus 4. And that gives us 10 cubed. Which, if you wanted to evaluate this completely, 10 cubed is 10 times 10 times 10, which is 1,000. The next one, it's still division, it's just written a different way. So 2 to the 12th divided by 2 to the 8th, they're the same base, so we can do 2 to the 12 minus 8 is 2 to the 4th. And then if we wanted to evaluate that, that would be 2 times 2 times 2 times 2, which is 16. And so that's the quotient property. When you do a power divided by a power, you subtract the exponents. Next one we're going to work with here, we'll see a pattern that evolves. So notice the pattern of the powers of 2, and we could do this with any power. We don't have to use 2, but we would notice the same idea. So notice as the exponents decrease, so our exponents are decreasing 4, 3, 2, 1, 0. The product, so the answer to this, is being divided by 2. We started with 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, divided by 2, so 16 divided by 2 is 8, and we kept dividing by 2, so 2 divided by 2 is 1. And so we see that 2 to the 0 power is 1, and that's going to hold true for all things to the 0 power. So any number to the 0 power is 1. In symbols, we could just say x to the 0 power is 1, where x just represents any number. So these 3 examples here should be really easy because any number to the 0 power is 1. So 221 to the 0 power, 1. M to the 0 power, 1. Well, this one looks kind of confusing. It's 31 x cubed y to the 4th z, all to the 0 power. Well, since it's to the 0 power, we don't have to worry about all the other stuff. It is 1. And so anything to the 0 power is 1. The last property we're going to look at is negative exponents. And so we have c to the 8th over c to the 12th, and we're going to simplify this in two ways. First, we're going to expand and simplify, so kind of what we did before. So c to the 8th over c to the 12th. These top 8 are going to simplify with the 8 of the bottom ones. And when that happens, these reduce to just have a 1 here. So this is 1 over c times c times c times c, which is c to the 4th. Next, what we're going to do is we're going to use what we just learned in the quotient rule to simplify this. This is c to the 8th divided by c to the 12th. Well, we can subtract our exponents, and we get c, 8 minus 12 is negative 4. Well, we solved the same problem in two different ways, and we did them correctly, so what has to be true about these two answers that we got? These two have to be equal. And so we can see that c to the negative 4th is really 1 over c to the 4th. And so our rule, or our property here, looks like this. X to the negative a. So if we have something with a negative exponent, that can be written as 1 over x to the positive a. So really what you do is you take that power to the denominator and you don't put the negative on it anymore. Another thing we can see is it says also 1 over x to the negative a. So here the negative a is in the denominator, which we can use our rule, our quotient rule, and then that simplifies just to x to the a. So if there's a negative in the numerator, a negative exponent in the numerator or denominator, it can be moved to the other one and you drop the negative. And so two examples here just to illustrate both parts of that rule. X to the negative 3, well, that's a negative exponent, so we can write 1 over, because now that's going to be in the denominator, and we can put a positive 3 there. And then with this one, we have a next negative exponent, but it's already in the denominator. So what we do is we move that to the numerator, and let me just be clear here when we write this. This is a fraction, so I'm going to write another fraction. This is going to move to the numerator, x to the 7th. Everything, any number you could think of as multiplied by 1, so this is just over 1. But then when we have over 1, we don't write it as a fraction, we just write x to the 7th, because anything divided by 1 is itself. So here are several examples we're going to work with to practice using these different properties. First one, 5 squared times 5 to the 10th. Well, that's a power times a power, so we're going to add those exponents. So this is 5 to the 2 plus 10, so this is just 5 to the 12th. Part B is the same idea. It's multiplication. There's 3 things there, so we're just going to add those 3 exponents because they're all the same base. 2 plus 4 plus 9. 2 plus 4 is 6, plus 9 is 15, so we have 3 to the 15th. Part C is division. Well, we learned with division, you're going to subtract the exponents. There's no exponent written with the second 2, so if there's not an exponent written, we know that's a 1. And so we can think, well, we're going to subtract the exponents to the 4 minus 1. 4 minus 1 is 3, so our answer is 2 cubed, or 2 to the 3rd power. Part D is another division, so we can subtract our exponents. 5 minus 3 is 10 squared, or 10 to the 2nd. I'm not multiplying them out because in the directions it says leaving each answer in exponential form. In part E, we have a power to a power, and so we learned when we have something like that, we're going to multiply the exponents. So that's 5 to the 18th, 3 times 6. Here we have some things we're going to evaluate. Now, evaluate does mean find the value of. So evaluate the following exponential forms. Some of these look familiar. We've we've done one like this first one before. This is negative 2 to the 4th. So that the negative 2 is in parentheses, so that means it's negative 2 times negative 2 times negative 2 times negative 2. Well, there's 4 negatives. We know when there's an even amount of negatives, that's going to be a positive. So we know that's going to be a positive answer, and then 2 times 2 times 2 times 2 is 16. So this is just 16. Now I'll write this out. We could write this as negative 2 times itself 4 times. And the reason I knew it was positive is because we have an even amount of negatives. We've talked about that before when we talked about multiplying rational numbers, that if you have an even amount of negatives multiplied together, you're going to get a positive. So that's how I knew it was a positive. And then 2 times 2 is 4. This is 4. And 4 times 4 is 16. This next one, this is negative 3 to the negative second. Now, we can think of this as we did before. It's not in parentheses, so this is a negative 1 times 3 to the negative second. And again, that's because there are not parentheses here. If there were, it would be different. And so here, let's simplify this. We learned that when we have a negative exponent, we can put 1 over 3 to the positive 2 power. And again, we are evaluating, so we're going to find this value. This is negative 1 times 1 over 9. Well, a negative times a positive is negative, so this is negative 1/9. Coming to part C. Here we have a negative exponent, so it's in the denominator. So what we can do is we can write this as just 6 cubed. This moves to the numerator, but we drop the negative, and this is just over 1. And so we have 6 cubed. 6 cubed is 6 times 6 times 6, which is 36 times 6, which is 216. So that's using those properties that we learned. A few more examples. Simplify, leaving each answer in positive exponential form. That actually is how you simplify. So when you have a simplified answer, you don't have any negative exponents. So part A, 3 to the negative 9 times 3 to the negative 7. We're multiplying, so what we're going to do is we're going to add these exponents. Negative 9 plus 7 is negative 2, but we can't leave it like that because we want positive exponential form. And so this is a negative exponent, so 1 over 3 squared. And we're not evaluating. It doesn't say evaluate. We don't have to find the value of it. It wants us to leave an exponential form. This one could be easily evaluated because 3 squared is not hard to find. Next one, it's multiplication again. So again, we're going to add these exponents. 2 to the negative 3 plus negative 2, which is 2 to the negative 5th. But we can't leave it as a negative 5 in the exponent because that's not simplified. So this is going to be 1 over 2 to the positive 5. Part C. This is division. So what do we do when we divide powers with the same base? Well, we can subtract. So this is 4 to the negative 2 minus negative 3. So be careful with the negatives. We know when we subtract a negative, that's the same as adding the opposite. So that's negative 2 plus 3. And so this is 4 to the first, which is just 4. And part D, this is a power raised to a power. We know we're going to multiply. So negative 3 times 4. So that's 5 to the negative 12. And again, we can't have a negative exponent. That's not simplified form, so we move that to the denominator, 1 over 5 to the 12th. And so here in this lesson, we defined exponents, its repeated multiplication, and then we looked at several of these properties of exponents.